Find each of the following integrals. And this is kind of a miscellaneous example. If we look at part A, 2x over x plus 1, you could do this, and probably the best way of doing it is a substitution, u equals x plus 1, and away you go. But we could do this as a type 4 partial fraction. Note it's an improper fraction because the power on the top, 1, is the same as the power on the bottom. So what we could do here is say, well, 2x plus 0 is being divided by x plus 1. So x to get 2x gives us 2. Then that's 2x plus 2 and subtract. And the remainder then is negative 2. So what we can do is write the 2x over x plus 1 as 2 take away 2 over x plus 1. So when we're integrating 2x over x plus 1, we can just integrate 2 take away 2 over x plus 1, and that would give us 2x take away 2 ln mod x plus 1 plus a constant. Now for the next one, that's definitely a type 1 partial fraction. We've got 2x plus 5 over x plus 1, which we can express as a over x plus b over x plus 1. If we then go clear of fractions, remember that means multiplying right the way through by x plus 1, we get 2x plus 5 is identical to a times x plus 1 plus b times x. Now, if I take x equals 0 here, that gives me 5 is equal to a. If I take x equals negative 1, that gives me 3 is equal to negative b, and that means that b is equal to negative 3. So what we're going to end up integrating is 5 over x, take away 3 over x plus 1, and that's going to give me 5 ln mod x, take away 3 ln mod x plus 1, plus a constant. And then finally, in part C, we've got 7x squared plus 8x take away 4 over x plus 1, x squared plus x minus 1. Now it's worth noting here that because of the minus 1, if you were to plot y equals x squared plus x take away 1, it would actually cut the axis. So we do have roots, and strictly speaking, you could factorize this. But if you try, it's going to have surds in it and stuff. So let's just treat it as if it's a quadratic factor. It does work if you do that. So it's a type 2, so we've got 7x squared plus 8x take away 4 over x plus 1, x squared plus x take away 1, and that is going to be a over x plus 1, that's how we deal with the linear factor, and then plus bx plus c over x squared plus x take away 1, that's how we deal with the quadratic factor. Okay, clear of fractions, 7x squared plus 8x take away 4 is going to be a x squared plus x take away 1 plus bx plus c times x plus 1. Now if I take x equal to negative 1, then what happens here? I'm going to get 7 from there, take away 8, take away 4. So 7 take away 12 is negative 5. And all of that would disappear with x being equal to negative 1. So we're going to get a into 1 take away 1 take away 1. So negative 5 equals negative a, means that a is equal to 5. Okay, let's look at x squared coefficients. On the left we've got a 7. So on the right we would have ax squared, which is 5x squared, and we'd have a b, and that tells me that b is equal to 2. And then let's look at constants. So on the left we've got negative 4, and we would have a negative a there, which is negative 5, plus a c. I didn't put the equals. So negative 5 plus c, and that tells me that c is equal to 1. And so what we're going to be integrating is 5 over x plus 1, and then we'd have 2x plus 1 over x squared plus x take away 1, and we can see that's going to be 5 ln mod x plus 1. And here the top is exactly the differential at the bottom, and so we can say that that is the log of x squared plus x take away 1. This time that modulus is actually needed because we know from our earlier discussion that x squared plus x take away 1 can be negative, and plus a constant